And welcome back, students, to our next lesson. In unit, we're going to be talking now about interfaces. So, getting started, a Java interface is something that specifies the set of methods that any class that implements the interface must have. Now, an interface by itself is a type which allows you to define methods with parameters of an interface type, and then have the code applied to all classes that implement the interface. So, one way to view an interface is that it's an extreme version of an abstract class. However, as we will see later on, an interface also allows you to do a lot more than what an abstract class can allow you to do. Now, another way to look at this is that interfaces are Java's way of approximating multiple inheritance. You can't have multiple base classes in Java, but interfaces kind of allow you to approximate the power of multiple base classes. If we think back to the beginning of the year, whenever we looked with derived classes and base classes, we always would have one base class followed by multiple derived classes. So this is kind of Java's way of sort of working around that. So an interface is something like the extreme case of an abstract class. But as we noted, an interface is not a class. It is, however, a type that can be satisfied by any class that implements the interface. An interface is therefore a property of a class which says what methods it must have. An interface specifies the headings for the methods that must be defined in any class that implements the interface. So, for example, the example below shows an interface named ordered. Public interface ordered, public boolean precedes, object other, for objects of the class O1 and O2, O1.follows O2 equals O2.precedes O1, public boolean follows object other. All right, that's it. That's the interface. Now, you'll notice that the interface only contains method headings. It's not specifying at all what's in those methods. It simply just says, here's the method headings. I'm going to expect those to be in your class. So it also has no instance variables, nor does it have complete method definitions, although as we can see, it can have constrained defined constants. Right? We don't have like any private instance variables or any public instance variables. You'll notice also in our parameters, we're using the object class. All right, so how do we actually implement this interface now that we've seen an example? So to implement an interface, a concrete class, which is a class other than that of an abstract, must do two things. The first, it must include the phrase implements interface name at the start of the class definition. So to implement more than one interface, you simply just list all the interface names separated by commas, such as implements some interface, comma, another interface. Two, the class must implement all the method headings listed in the definitions of the interfaces. So for example, to implement the ordered interface, a class definition must contain the phrase implements ordered at the start of the class definition, as shown in the following: public class ordered employee, extend hourly employee, implements ordered. Then the class must also implement the two methods precedes and follows as shown within ordered hourly employee. And if we hop over to Eclipse real quick, take a look at that. Here's our ordered right here, and you can see, just as we saw in the example, there's nothing really here. These are just a single line, and notice they end with a semicolon. You don't have to use curly brackets on these. And over here is our hourly employee. Ordered hourly employee extends hourly employee, implements ordered. Here is our precedes method. And you'll notice here that the method is fully defined now. All right. Before, we just had the method header. Here's our follows one. And again, you'll see that it is now fully defined. So when you make your interfaces, you don't have to fully define them, because those are going to be defined within the individual classes. All right, and now an interface and all its method headings are normally declared to be public, because you want them to be able to be accessed. They cannot be given private, protected, or package access. Now the modifier public may be omitted, but all the methods will still be treated as if they are public. When a class implements an interface, it must make all the methods in the interface public. Now, as we mentioned, an interface is a type. Because it's a type, this allows us to write a method with a parameter of an interface type, such as the parameter of type ordered, and that parameter will accept it as an argument any class you later define that implements that interface. You'll notice when we had our parameters, they were just objects. We weren't specifying a string or int or anything like that. An interface also serves a function similar to that of a base class, but it's important to note that it is not a base class. In fact, it's not a class of any kind, if we haven't hammered that into your head by now. Some programming languages, such as C++, will allow you to have one class to be a derived class of two or more different base classes. All right. But this is not allowed in Java. All right. So Java doesn't let you do that. In Java, a derived class can only have one base class. However, In addition to any base class Java may have, it can also implement any number of interfaces. This allows Java programs to approximate the power of multiple base classes without the complications that can sometimes arise with multiple base classes, because you have to keep track of everything. You might also want to say that the argument to proceeds in the order interface is the same as the class doing the implementation. So, for example, order hourly employee. All right, we just simply added the order down there so we can kind of keep track of that to know that it has the interface. Now, because there's no way to say this in Java, we normally just make such parameters of type object. Hey, there's our parameters. We have an object type. It would be legal to make the argument of proceeds to type ordered, but that's normally not preferable to using object as the parameter type, because when you make it ordered, it's going to really kind of start restricting stuff. If you make the argument type ordered, you'll still have to handle the case of null, our good old friend null, and the case of an argument that, while is ordered, is not of type ordered hourly employee. So that is part of the reason why we don't change it off object, because we start having to deal with these more nuanced situations like this. Now, interface definition, of course, is stored in a .java file and is compiled just as if it was a class definition. All right, even though it's not a class, Eclipse or whatever compiler you're using is going to do it in the exact same fashion. All right, now abstract classes can also implement interfaces. Now, as we saw previously, we did a concrete class, which is just our regular Java classes, which must give definitions for all the method headings given the interface in order to implement the interface. However, we can also define an abstract class that defines the interface, but only gives definitions for some of the method headings in the interface. The method headings given in the interface that are not given definitions are then made into abstract methods. So a simple example is shown here in our class material. So we'll pop over to Eclipse once more, and you can see right here is my abstract class. Okay, and you can see right here is the proceeds method. You can see it's fully fleshed out just like before. But when we look at our follows method, boom, this is it. All right, we don't have anything else to it, but we did add this word abstract. All right, so even though we're not fully implementing it because we don't have all the stuff fleshed out underneath, we still have to have it there with the word abstract. So that's how abstract methods can kind of get around that. All right, now let's say we want to extend the interface. So you can derive an interface from a base interface. It's kind of like how you can have a class, bake into a derived class. This is also sometimes known as extending the interface. Now the details are similar to that of deriving a class. And if we look at our example, all right, so we ordered, you can see we say public interface show by order extends ordered. And it simply just outputs an object of the class that precedes the calling object. So public void show one who proceeds. And that's it. That's all the method in. So that means if you implement this, show by ordered, you're using the extension. Now there is a pitfall. Interface semantics are not enforced because as far as Java compiler is concerned, an interface has no syntax, but no semantics really to worry about. So if we want to kind of make it a little more concrete, for example, the definition of order interface is the following in a comment. For objects of the class O1, O2, O1.follows, O2 equals O2.proceeds, O1. Now, we might have assumed that this is true even if there was no comment in the interface. I mean, it's pretty easy to understand what proceeds and follows means. After all, in the real world, if I precede you, then you follow me. It's pretty straightforward. However, remember, computers can be dumb. All right, and right now, if we think about that, we're using our own intuitive interpretation of the word proceeds. Computers, like I said, can be really dumb. So, when we look at this from the compiler and runtime perspective, the order interface merely says that the methods proceeds and follows each take one argument of type object and return a Boolean value, whether it's true or whether it's false. That's all the compiler cares about. The interface does not really require that a Boolean value be computed, though, in any particular way. So, for example, the compiler will be satisfied if both proceeds and follows always return true. Or if they always return false. It doesn't care. It's met its conditions. It's happy. It would even allow the methods to use a random number generator, let's say, to generate a random choice between true and false. So it could just randomly pick true, and it could randomly pick false. The compiler is happy because it's meeting its conditions. Now, it would be nice if we could say the given interface some simple semantics, such as saying that O1.follows O2 means the same as O2.proceeds O1. However, the kind of the kicker here is that if Java did allow that, there would be probably having a class implement two interfaces or even with having a class derived from one base class and implementing an interface. So either of these situations could produce two semantic conditions, both of which must be implemented for the same method, and then the two semantics may not be consistent. So for example, contrary to fact, you could require that O1.follows O2 means the same as O2.precedes O1. You could also define another interface with inconsistent semantics, such as saying that precedes always returns true and that follows always returns false. And as long as a class can have two objects, there's no way a class can implement both of these semantics. Interfaces in Java are therefore very well behaved, which is kind of the price that we have to pay so that we can't count Java to enforce the semantics. All right. If we want to require semantics for an interface, we actually can add it to our documentation as illustrated with the comments in order and shortly ordered. But remember, these are only comments. They're only there for the programmer. The compiler itself doesn't really know. It's great for the programmer because they understand that, okay, this is how the method's being used for follows, this is how the method's being used for proceeds. But the compiler, like I said, as we looked at this pitfall, doesn't really care. They are not necessarily enforced by the compiler or the runtime system, so we can't just rely on semantics to be followed. However, because we live in an imperfect world and sometimes you find you must specify semantics for an interface, please make sure that when you do so, you specify that in your interface's documentation. Therefore, the responsibility then shifts from you to the programmers implementing the interface to follow those semantics. So documentation is a very important thing here. All right, now that we've made our point about interface semantics not being enforced by the compiler runtime system, we want to make sure that nonetheless, pretty much you're following the specified semantics for an interface. So even though, yes, Java doesn't care about semantics, please make sure you're following it. Software written for classes that implement interface will assume that any class that implements the interface will satisfy the specified semantics. So if you define a class that implements an interface but does not satisfy the semantics for the interface, then software written for classes that implement the interface, well, they're probably not going to work for your class. So when you define a class that implements that interface, then the compiler runtime system will let you define the body of an interface method any way you want, provided you keep the method heading as it is given an interface. However, you should follow the specified semantics for an interface whenever you define a class that implements that interface. Otherwise, any software written for the interface just may not work for your class. All right, and that's going to be about it for today, folks. Kind of a little bit of a lengthy introduction here, but we are now into our first step into a large world. So we'll see you next time.